Hi everyone, so this video is going to be an explanation of a project I've been working on called FuelMapper. The idea behind FuelMapper is that it's really hard as a triathlete to plan your fuel during a race, especially during an Ironman, which is a 2.4 mile swim, 112 mile bike, and a marathon. So the purpose of the site is to chart your available calories and how that changes as you eat so that you can understand if you're getting enough calories during the race to basically finish and not bunk. So when I was first showing this to people, a lot of people didn't understand the sort of science behind it, so I made a landing page that goes over the basics. First tells you what the site does, which is take your Ironman data that you input and convert it into something useful, which is a chart that shows you your calorie usage over the course of the race. And also explaining the difference between carbohydrate calories and fat calories, because you use both during an endurance race, roughly half depending on your pace, and you can replenish carbohydrate calories, but you can't replenish fat. So when you're eating, the carbohydrate calories are what you care about because that's what you're trying to replace. So after that brief explanation, it would bring you to this form you would fill out. So I'll just add some numbers here, which is validated based on what would be reasonable for this. So here's some numbers. And there's also a fuel suggestion portion of this, so that's why I have the flavors here. This would create your chart, which is made through D3, which is kind of why I did this project, is because I wanted to learn D3. So these are all SVGs, which I've bound the input data to so that they reflect what the user inputted. So what this graph is showing you is the carbohydrate calories you'd be using over an Ironman race. So there's a big dip here at the beginning because when you swim you can't eat. So you have an automatic big dip there. And then there's uniform increase and decrease here because this is assuming you would eat 250 calories per hour. So that's why you see these uniform lines here. And the graph would show you your total time up here for the race, which could be anywhere from 8 to 17 hours. And the graph will actually adjust based on that size. So here I have someone who has a longer race and their chart is bigger. And then for each hour, you could hover over to see how many calories you had available. And the purpose of this is to show you that if your lines go off the graph, which means you're running out of carbohydrate calories, then you need to be eating more per hour. So we used a baseline of 250 calories. So this person might need to take in more than 250 calories to keep up with the rate they're burning. So I have this chart over here which explains these things a little bit. The most important thing here is it gives you your individual burn rates for swim, run, and bike, so you understand where your calories are going here in this graph. And it also explains that you have a stored amount at the beginning, which for this person is 1,700 calories, which is where you're starting here. You could clear this and do it again if you thought your numbers are wrong. You can also go down here to some fuel advice, which is just basically options that went along with your flavors that you chose. Gives you a little information about each if you hover, and then of course if you click, it's going to take you to the site to buy them or learn more about them. So that's the basic idea of my site. Now let's look at the JavaScript for a second. I'm starting with, on that click, displaying a bunch of stuff that was hidden. Then I'm getting the information from the user input with serialize, and then I'm turning that into the information that I want. So I'm making a new object and transforming all that. So I'm figuring out their stored glycogen value based on their weight, their swim burn rate based on heart rate, weight, age, and gender, and then run and bikes based on weight and their paces, and the total time based on their paces and the distance of this race, which is an Ironman. I stored that in local storage in case I need it later, and then I go about turning that information into data that can be used by D3. So basically with D3, you bind data to SVGs, and then you can access it when you're changing the attributes of those. So I'm getting all that data, the points that I want for the graph, and then here is where I'm actually using D3. So first you make a canvas basically, and then I'm adding a polyline, which is the line on the graph, and that I've bound the data that I wanted to it. So then when I change the attribute points, I just have a function of that data and it gets the points for me. And that's the same thing with the circles that are here that you can hover over, and the total time text. And then I'm calling those because I made those functions. And then I'm adding the chart here, making that toggle, side toggle. And then I made an array of fuels based on your flavor choices, and then shuffled them and printed out 5 so that it wouldn't be the same every time if you did this multiple times. And then here I'm just adding the mouse enter and mouse leave functionality for the circles so that when you're over the circles, you can see the exact calories at that point. Yeah, basically that's the whole project, and I'm excited to try animating this graph because I think that would improve this a lot, and also make maybe a calorie intake suggestion instead of using a model of 250. So those would be the improvements I would make. But thanks for listening.